Hello dear students, welcome to the lecture series of Object Oriented Programming. In this lecture, we are going to see abstract class, abstract base class for common interfaces, dynamic binding and message passing principles of Object Oriented Programming. At the end of this lecture, you will be able to introduce abstract class, you will be able to explain the uses of abstract class as well as principles of Object Oriented Programming like dynamic binding and message passing. Let us see what is an abstract class. Abstract class is a class which can be initiated. Although some methods are available in the abstract class, you cannot make an object or instance of an abstract class. They are considered as incomplete classes. The abstract class has one or more pure virtual function, pure virtual member function, which is considered as an abstract function, and those abstract functions do not have any body. Those abstract functions must be implemented by the derived classes. Abstract class is used in the situation when we have a partial set of implementation of methods in a class. Let us consider a class which have 4 methods. Out of those 4 methods, we have an implementation of 2 methods in the class itself, and we have derived class to implement other 2 methods. Now, whatever the other 2 methods derived class has implemented, those 2 methods will be declared as an abstract in the abstract class. Now let us see how an abstract base class will be useful for the common interfaces. Abstract class is used when you want to design an application where you have some common functionality, and that common functionality will be declared in terms of common methods or in terms of common interfaces. You would like to share that functionality, that is those methods and those interfaces, in all the other child classes. You want the derived classes to be free to use and develop the other methods which will be declared as abstract in the parent class, that is in the abstract class. In other words, whenever we have a scenario where we have to create a multiple related classes having is a relationship, then we need to put all the common features, that is all the common methods, all the common interfaces in an abstract class, and let all other classes which are derived from this abstract class perform the action or perform the operation. Please remember that is a relationship is a inheritance relationship. So of course a superclass and subclass concept will be available. The derived classes will be subclasses of the abstract base class. Common features of the abstract class can be further enhanced in future, and the changes or enhanced features will be available in the derived classes without any issue. Now, here the abstract class is working as a base class for all the common interfaces. What are the common interfaces? These common interfaces are the methods which are implemented by the derived classes, which are implemented by the different derived classes as per their need, as per their requirement. We need to create an abstract class as a base class because it will transmit its default features to the derived class. It will create a derived class from this abstract class, abstract base class, performing a similar type of function. The abstract class allows us to define a standard behavior but also provides us a feature to override it if we want to do it. We have already gone through the concept of function overriding. Now let us see an example of abstract base class which is used for common interfaces. Let us consider a base class as a shape which has her subclasses as triangle and rectangle. Triangle and rectangle inherit the shape class. Now suppose we need a function to return an area of a shape. The function will be declared in the shape class. Now that function will be declared, that method will be declared in the shape class as a abstract method. Why? Because rectangle and triangle have the two different formulas to calculate their areas. So if we write a definition of the area in the shape class, it will not be feasible by the to use for the rectangle class and to use for the triangle class. So what that rectangle and triangle class will do, they will inherit that functionality, but they will implement the formula in their own method by using their own definition. So the pure virtual function will be used to calculate the area, and it will be implemented differently by each subclass. That is, it will be implemented differently by rectangle class and by the triangle class, and that method will be declared as an abstract method in the shape class, which is an abstract base class for the common interfaces for that is for rectangle and for the triangle class. Why do we create a class as an abstract class when we could have created them as a concrete classes? These classes are providing a template or a common functionality to their derived classes without keeping themselves incomplete. While keeping themselves incomplete. Now, you know what is concrete class. Concrete class is a class which can implement all its method and all its functionalities, and that concrete class can can have the subclasses, and that subclasses can inherit the all the properties and all the functions of the concrete classes. Still we have to create a abstract class, because the abstract classes are providing a template or common functionality to their derived classes while keeping themselves incomplete. And what the derived classes will do, derived classes can derive those methods from the abstract base class, but that derived classes may have a different definition from the abstract class. We do not want anyone to directly use the abstract classes, which means we do not want anyone to create an object for the abstract class and start using the abstract class, because these base classes contain a basic framework or skeleton or template for their child classes, and there are number of child classes for this abstract classes. So there can be a single abstract class, or that there can be a abstract base class for all the common interfaces, for all the derived classes who want to use that common functionalities or common interfaces. Now let us see one of the principle of object oriented programming, that is dynamic binding. Now what is dynamic binding? Linking of a procedure call to the code to be executed in response to the call is referred as a dynamic binding. It means when the code is associated with a given procedure call is not known, it means the code associated with a given procedure call is not known until the time of a call at runtime. Now let me give you a simple example. Now for example, you have two functions. One function is calling another function. Uh, Unless and until that function is called, the another function, that is function 2, is called by function 1, the function 1 will not be able to know the functionalities or the implementation details of function 2. So when that function will able to know those implementation details at the runtime, when that function will be actually called, when the function 2 will be actually called by the function 1, at that time the details will be available. That is called as a dynamic binding. In C++, compiler match the function calls with the correct definition at the runtime, and that is called as a dynamic binding or late binding, or it is called as a runtime binding. The dynamic binding is achieved using the virtual functions. Base class pointer points to the derived class object. The function is declared virtual in the base class, and then the matching function is identified at the runtime while virtual table entry is used. Now let us see the next principle of object oriented programming, that is message passing. And object oriented programming consists of a set of objects that communicate with each other. So the process of programming in an object oriented programming involves creating the classes that define the objects and their behaviors, creating the objects from the class definitions, and establish the communication among these objects. Now, these objects communicate with each other by sending or receiving the messages or sending and receiving the information. Message passing involves specifying the name of object, name of function, and information to be sent. Uh, for an example, if an object employee wants to send some message to another object, then uh, then the syntax as employee dot salary in brackets name will be considered for sending the message from that employee object. Here employee is object, salary is the message, and name is the information. So this is a message passing, one of the basic principle of object oriented programming. I hope you have understood the abstract class and the abstract base class for the common interfaces, and why do we have the abstract classes, as well as two principles of object oriented programming, that is dynamic binding and message passing. So we will meet in the next lecture. Thank you. Happy learning.